Hi students, today we will discuss the next topic, biosynthesis of purine nucleotides. Purine nucleotides. Purine nucleotide means adenosine monophosphate and guanosine monophosphate. Adenosine monophosphate and guanosine monophosphate. Purine nucleotides are synthesized either by de novo synthesis or by salvage pathway. First we will discuss about de novo synthesis. See, many compounds contribute to the purine ring of the nucleotides. We have to see that first. Okay, I will draw the structure of purine. C N N N N. This is the structure of purine. Okay, and numbering 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, see here N1 of purine. N1 of purine is obtained from aspartate. N1 of purine is obtained from aspartate. Then second position carbon. Second position carbon and 8th position carbon C2 and C8 are obtained from formyl tetrahydrofolate. So carbon at the second position and carbon at the 8th position are obtained from formyl tetrahydrofolate. Then N3, nitrogen at 3rd position and nitrogen at 9th position. N3 and N9 are obtained from glutamine. N3 and N5 are obtained from N3 and N9 are obtained from glutamine. Then carbon at 4th position, carbon at 5th position and nitrogen at 7th position are obtained from glycine. C4, 5 and 7. The next carbon at 6th position, carbon at 6th position obtained from carbon dioxide. So these are the compounds contributing to the purine ring. N1 is from aspartate, C2 and C8 carbon at 2nd and 8th position from formyl tetrahydrofolate, nitrogen at 3rd position and nitrogen at 9th position obtained from glutamine, carbon at 4th position, carbon at 5th position and nitrogen at 7th position obtained from glycine, carbon at 6th position obtained from carbon dioxide. Okay. Then now we have to see some easy tricks for studying this biosynthesis of purine nucleotides. There are 11 steps till the synthesis of inosine monophosphate. Inosine monophosphate is the base purine nucleotide, inosine monophosphate. Okay, see 11 steps are there for biosynthesizing inosine monophosphate. In that, first, 3rd, 5th, 6th and 8th step requires ATP. First, 3rd, 5th, 6th and 8th step requires ATP and the enzyme catalyzing these reactions are synthetase. Enzyme catalyzing first, 3rd, 5th, 6th, 8th steps are enzyme synthetase. Then we have to remember 2nd and 5th step requires glutamine. 2nd and 5th step requires glutamine. 3rd step requires glycine. Third step requires glycine. Fourth and 10th step requires tetrahydrofolate. Fourth and 10th requires tetrahydrofolate. Seventh step requires carbon dioxide. Eighth step requires aspartate. And this is the requirement. And in ninth step there is elimination of formate. And 11th step there is elimination of water. So this we have to remember. If you are remembering this the biosynthesis of purine nucleotides will be easy. See, first, third, fifth, sixth, eighth step requires ATP, and the enzyme catalyzing these steps are synthetase. Second and fifth step requires glutamine. Third step requires glycine. Fourth and 10th step requires tetrahydrofolate. Seventh step requires carbon dioxide. Eighth step requires aspartate. Then in the ninth step there is elimination of formate. Then in the 11th step there is elimination of water. Okay, this much if you are remembering, it will be easy for studying de novo synthesis of purine nucleotides. Okay, now we will start the purine biosynthesis. See, purine nucleotide is synthesized on a pre-existing ribose sugar. Okay, I will draw a ribose sugar. Pre-existing ribose 5-phosphate. See, this is ribose 5-phosphate. Okay. See, ribose 5-phosphate. The enzyme, first step requires, I told you, ATP. ATP is converted into AMP. Here 2 phosphate group are utilized. Remember, 2 phosphate groups are utilized. Already we have studied the enzyme catalyzing first step, it is synthetase. Enzyme synthetase. Okay. So again I am drawing ribose sugar. CH2O. This is ribose sugar. Here the hydrogen is replaced by 2 phosphate groups. So this is the change in first step. This is the step 1. Step 1 requires ATP and the enzyme catalyzing the reaction is synthetase. Okay, this is phosphoribosyl pyrophosphate. So we can call the enzyme catalyzing this step to phosphoribosyl pyrophosphate or PRPP, phosphoribosyl pyrophosphate. We can call it as PRPP synthetase. Okay. Then in the second step, glutamine is required. See, we have studied already. Say in the second step, glutamine is required. Glutamine is converted into glutamate. That is, one amino group is transferred from glutamine forming glutamate. The enzyme catalyzing the reaction is PRPP glutamyl amido transferase. PRPP glutamyl amido transferase. Pre-existing ribose sugar, H2O. Here the change is a pyrophosphate is eliminated and a amino group is transferred to the position. Okay. This is phosphoribosylamine, 5-phosphoribosyl ribosylamine, 5-phosphoribosylamine. Okay, 5-phosphoribosylamine. This is the second step. And coming to the third step, again we have told third step requires ATP and enzyme catalyzing the reaction is synthetase. Third step is synthetase. It requires ATP. ATP is converted into ADP. Again we have studied third step requires glycine. Third step also requires glycine. Okay. So ribose sugar, CH2OP, H, NH. So from CO, that is a carboxylic acid position, hydroxyl group is eliminated. CO, CH2, then NH2. NH2, CH2, COH, that is glycine. So OH group is eliminated. So the carbonyl carbon attaches to the nitrogen. So this is the glycine part. CH2, NH2. Glycinamide, ribosyl 5-phosphate. Glycinamide, ribosyl 5-phosphate. Okay. Then in the fourth step requires tetrahydrofolate. Methynyl tetrahydrofolate is converted into tetrahydrofolate, and tetrahydrofolate formyl transferase. Enzyme catalyzing the reaction is formyl transferase. Formyl transferase. Again ribose sugar, H, NH, CO, CH2, NH, COH. This is the change. Formyl group is attached to glycinamide ribosyl 5-phosphate. So it becomes formyl glycinamide, ribosyl 5-phosphate. Okay. Then the fifth step. See, we told fifth step requires ATP. ATP is converted into ADP. Then fifth step also requires glutamine. Glutamine is converted into glutamate. Enzyme catalyzing the reaction is synthetase. So I am not writing again ribose 5-phosphate. See, ribose 5-phosphate. In that NH, see that double bond here, oxygen is eliminated and one NH group is attached here. Then CH2, NH, C double one H. This is formyl formyl glycinimidine ribosyl 5-phosphate. So the first step, this de novo synthesis starts from a pre-existing ribose 5-phosphate. Then in the first step, synthetize enzyme and ATP, it converts into phosphoribosyl pyrophosphate, and in the second step it requires glutamine, glutamate amidotransferase enzyme converts into 5-phosphoribosylamine. Then in the third step, again synthetize and ATP, glycine is required in this step. Glycinamide ribosyl 5-phosphate is synthesized. Then in the fourth step, formyl transferase, methynyl tetrahydrofolate is converted into tetrahydrofolate. A formyl group is attached and it forms formyl glycinamide ribosyl 5-phosphate. Then in the fifth step, ATP is required and the enzyme synthetize. In the fifth step also requires glutamine, and carbonyl oxygen is replaced by NH group. Oxygen is replaced by NH group and forming formyl glycinimidine ribosyl 5-phosphate. That is the fifth step. Then coming to the next step, sixth step. Sixth step again requires ATP. ATP is converted into ADP. Enzyme catalyzing the reaction is synthetase, and here cyclization occurs. Ribose 5-phosphate, in that NH, C double bond NH, it is converted into NH2 amino group. CH, okay, cyclization, okay, here it is CH, here also it is CH. This is 5-amino imidazole, 5-amino imidazole ribosyl 5-phosphate. Ribosyl 5-phosphate. This is the sixth step. Then the seventh step. Here a molecule of carbon dioxide is added. Carbon dioxide is required for the seventh step. Already we have told. Carboxylase enzyme. This is already pre-existing ribose 5 sugar, and to this imidazole ring at fourth position a carboxylate gets attached. So that is 5-amino imidazole, 5-amino imidazole carboxylate, 5-amino imidazole carboxylate ribosyl 5-phosphate. That is the seventh step. And in the eighth step also requires ATP converted into ADP. Here aspartate is also required. And eighth step also enzyme catalyzing is synthetase. synthetize. N NH2 ribose 5-phosphate C double bond O NH. This is the NH CH COH CH2 COH. This is aspartate. Aspartate gets attached to the carbon on the carboxylic group, carboxyl carbon, okay, or carbonyl carbon. 5 amino imidazole, 5 amino imidazole, 4 succinyl carboxamide ribosyl 5-phosphate. Okay, this is the 8th step. Now the 9th step. Ninth step we already told, it's the elimination of aspartate, fumarate. Fumarate means COH, CH2, CH2, COH, and this group is eliminated. Adenosuccinate lyase. Enzyme catalyzing the reaction is adenosuccinate lyase. Here only that NH2 remains. Okay. So this is 5 amino imidazole, 5 amino imidazole, 5 amino imidazole, 4 carboxamide ribosyl 5-phosphate. Okay, then coming to the 10th step. 10th step requires tetrahydrofolate, THF, methenial tetrahydrofolate is converted into tetrahydrofolate. Enzyme is formyl transferase. Formyl transferase, it is in ribose 5-phosphate NHCOH. This is the change. COH. Formyl group attaches to the 5th position nitrogen. Substitution. CONH2. This is 4 amino 4 carboxamide ribosyl 5-phosphate. Then in the 11th step there is elimination of water. And ring cyclization occurs. Cyclohydrolase. Cyclization occurs and it forms ribose 5-phosphate. CON N okay, this is inosine monophosphate. This inosine monophosphate is having a purine base, purine nucleus. So from this inosine monophosphate, purine nucleotides are synthesized.